You're tuned into our webinar brought to you by our sponsors, Seaber, improved awareness of commercial opportunities, speed and accuracy of decision-making with AI. Leading a presentation today are our guest speakers from Seaber, CTO and co-founder Mikael Sand and Artu Vitanan, VP of Product. Leave your questions with upvotes in the Q&A section of your screen. Over to our CEO, Carl Jeffrey, to lead the talk.
So our topic today is how we can use advanced AI tools to connect vessels and cargoes, and how charterers can get a better overall outcome with AI-based tools than they can using spreadsheets or traditional software. So say you're in the commercial department of a shipping company and you've got 5 open vessels in the Far East and you know about 300 cargoes looking for vessels. How do you work out which cargoes to go for? And like everyone in shipping, you've got all your information in thousands of emails and WhatsApp messages. So you could put the data in a spreadsheet or voyage management system and try to do the modeling in a traditional way, or you can use AI. And there's 3 AI components to the software that we're presenting today. One is a data parser, which takes data out of all of your sources, so email, WhatsApps, ERP systems, and puts the data together in a structured format which other systems can talk to. And the second AI component is the optimization algorithms. We might call this conventional AI or data analytics. It's working out which cargoes will give us the best daily earnings, taking into account whatever factors and constraints we set. And the third component is agentic AI, which is based on large language models. The agentic AI talks to the outputs of the data parser and the optimization algorithms, and then it'll generate scenarios you can consider. Our first speaker today is Arto Vietanen, Vice President of Product with Seaber. He's got a background in user interface and user experience design. Our second speaker is Mikael Sand, co-founder and CTO of Seaber. He has a background in risk analytics and natural language processing. Seaber is based in Espoo, which is just outside Helsinki. We're going to have a talk from Arto and Mikael of about 30 minutes, and then we'll take your questions. You can put your questions in the Q&A box at any time, but we'll take them at the end. And I'd like to invite Arto to start your talk.
Thank you, Carl. Let me start the screen sharing. Okay, I'm going to skip the first slide and go directly to the agenda. So I have a few slides, or we have a few slides, and then there will be a demo where we show a little bit of our software. So we're going to be talking about the current challenges in the pre-fixture process, all the different kinds of data that you need to utilize in commercial decision making. And then we're going to be talking separately about the 3 different types of AI that Carl already mentioned. So let's move on. This slide was brought by our marketing into the deck, but it's the interesting part here is the different segments where we work. So we have a software solution for doing scheduling and chartering decisions, pulling in a lot of data. You'll see that in just a moment. And currently we are strong in multi-parcel shipping segments such as break bulk, chemicals, CPP, etc. But we also have some commercial dry cargo owners, primarily in the short sea segment. But really our software can be used in a lot of different contexts, both charterers and so cargo owners and ship owners can both utilize our software depending on the setup. And here we have some logos of our customers, and then I'd like to maybe point out a couple of integrations or key integrations we have. So we're using a lot of data from voyage management systems, especially Vesson, which I guess everyone knows is the market leader. Then we have partnership with Sedna. So for example, from Sedna Pulse, we can bring in market cargo inquiries, so parsed emails. And then Nappa is a close partner of ours. We use them for a lot of different kinds of data. So moving on to the next slide. So I made this beautiful diagram that illustrates a typical chartering process without Seaber. So if you work in chartering, or at a ship owner, I'm sure you're familiar with these steps. So at the center of everything is typically the voyage management system, voyage estimator, where you run voyage estimates. So you pick cargoes manually into it, and then you run estimates for individual voyages. So you get the P&L, profitability, and TCE, and those things calculated. Typically, before that, you need to get the cargo somehow into the system. And I know a lot of companies are doing this manually. So entering the cargo details first, and then combining those into voyage estimates on vessels. But since this has quite many limitations, it usually forces people to look at maybe 1, 2, 3 open positions at a time, because otherwise the complexity just kind of gets out of hand. When you're doing the voyage estimates with traditional tools, you oftentimes need to jump between different software and different spreadsheets to look up different details that might affect your decisions. I'm going to go through those real quick. So draft restrictions. Well, if you're calling a port several times a month, then you probably don't need to check this. You will have a good gut feeling for it. But for a little bit more exotic ports, you will need to check what the terminal draft limit is and calculate the actual draft of the vessel entering or leaving the port. Then you need to check often. You need to check previous cargo exclusions. Sometimes it's straightforward. Sometimes it's more complicated. You might need to open a cleaning matrix to look at like what do you need to do in order to load this cargo. And stowage plan is another element that is linked to the previous cargo, but also for break bulk or chemicals, you will often need to get the stowage plan checked before you can, before you can even know if you can load the cargo or not. Then jumping over to the left side, port costs. Sometimes people just use their gut feeling that, yeah, this is around 40,000 at this port with this class vessel, etc. Or then they look up previous DA values in the voyage management system, or they might use a third-party service to estimate the port costs. Again, some jumping between context switching and so on. Weather adjustment, oftentimes people will just use the same number every time, like 5% here, or maybe 10%, or whatever it is. So it's not very accurate. Then we have vessel speed and consumption. So you might end up iterating on the vessel speed to understand the impact it has, finding the optimal speeds in order to meet the laycans and still and maximize the TC at the same time. Port stay duration, congestion, etc. You might be jumping to another service to look up congestion, waiting times, or like how long will this cargo operation take at this port, etc. And then finally, market vessels, because this impacts obviously your negotiation leverage for the freight prices, etc. You need to know what competition is doing, so you will look up open position lists in emails or some other services. So there's a lot of stuff that goes into the voyage estimate process. Then if you make decisions for one vessel, those decisions will affect what you do with second or third vessel as well. So quite often we've seen people then go into a spreadsheet and sort of summarizing or copying values from the voyage estimator into a spreadsheet to do like this mini scenario, so that you understand which of these options for 3 vessels, for example, looks like the most attractive one. At that end, you end up in some sort of iteration loop, often in this, and then finally you have an understanding of which cargoes are the most attractive ones, and then you negotiate and fix business as usual. Not very surprisingly, the next slide is the same process using our software. You'll see some parts of this in a demo in just a moment, but I'll go through these boxes anyway. So first of all, we have a lot of data automations to bring in those very same boxes that you saw on the previous slide, different restriction checks, the durations and costs of the different things. So we we automate this data to be flowing into Seaber, we normalize it, and then it's all you have to do is drag and drop things around or use suggestions in the software, and all of this is accounted for kind of automatically. We have several ways of getting in cargoes as well. Already mentioned Sedna, but we can also bring in, or it's a pretty common thing to from a customer to ask for us to be able to bring in some messy spreadsheet with cargoes. Like, for example, the chartering desk has been putting together a spreadsheet with potential cargoes. We can just simply import it and not have to worry about what the commodities or the ports, how they are called, etc. So we can normalize everything. And we don't really force you to focus on one vessel or two vessels. You can focus on any subset of the fleet, and you can get, for example, an understanding of what to do with, if you have 9 vessels open in a region, in some region next month, you can look at all of them. And then we generate, basically, we calculate loads of P&Ls for any possible combination that each vessel or the fleet can do. So then it's up to the user to select out of the suggested things, tweak and compare individual voyages, and then finally end up with scenarios. Scenarios could be, for example, for those 9 vessels or for the whole fleet. So you can create different scenarios, and then by comparing them, you understand which of those scenarios has the best profitability for the overall fleet, or overall fleet profitability, or then capacity utilization. And then once you understand which are the best cargoes, what are the best scheduling and chartering decisions to make, then you go and fix those cargoes. One more slide by me. So this was, in practice, how do we use large language models to process data in Seaber? So we have self-hosted LLMs. We're using a few different models for different purposes. So we have those running, and then we can pass on any kind of data to them, and then the data gets parsed and normalized, and that so that we can just inject them into our data schemas or our database, basically. So some examples: dictation of cargo. So you can talk to for example, do it on your phone. You can dictate a cargo and then straight away understand, do you have any vessels for it, or any existing voyages that would have capacity for them, etc. Cargo spreadsheet, I already mentioned. External API data, this is an interesting one, because sometimes, for example, commodities or port names are spelled differently in different data sets. So in order to be able to use that data, then there's normalization and parsing of this data needed. Again, we use the same mechanism for that. And then internal spreadsheets. This could be anything. I mean, companies have all kinds of data in spreadsheets. It could be, for example, a cargo compatibility / cleaning matrix. So if you're switching from this cargo to that cargo, how much money and time do you need for cleaning, or is it even allowed to load that cargo? That sort of stuff. All right, then I'll ask Mikael to talk about agentic AI. Please go ahead.
Yeah, thank you, Otto. So we're currently developing agentic AI for Seaber. For this, we're using the Model Context Protocol. This is an open standard made by Anthropic, one of the largest large language model producers at the moment. This enables connecting large language models to our tools. So this can utilize all of our existing visualizations and calculations and KPIs to search for improvements to our scenarios. Or, for example, if you have delays due to port congestion, bad weather, or cargo delays, or, for example, technical problems with your vessels, you can search for alternative schedules to resolve these lake-hand issues, for example. Next slide, please. And then we have a couple of optimization algorithms. So these are mainly 2 categories. First one is the analytically optimal solver. So this one does a exhaustive search, and therefore it can take a long time to compute if you have a bit bigger fleet or a larger number of cargoes. But this also guarantees optimal solutions in terms of your objective. But then if you have too large fleet or too many cargoes to consider the exhaustive search, then we have the heuristics and meta-heuristics. This can provide you feasible suggestions quickly, and if you have the patience to wait, then you can have it compute longer in the background, and it will provide better and better results over time. So this can handle fleets of more than 100 vessels and thousands of cargoes. Next slide, please. And for the future, we're developing a AI-based schedule optimization algorithm. For this, we're generating lots of problem instances to get representative problems of different kinds of situations. These we feed into our optimization algorithms to find both the optimal solutions for the small ones and good solutions for the others. This then becomes the training data, which we use to train a foundation model. And then we can further improve this using reinforcement learning from verifiable rewards. This means that the deep neural network generates a large number of possible solutions. We feed this into our existing tools to calculate all the KPIs, and if they improve, then we will reinforce these or reward those activations in the neural network. Then we have fine-tuning. So per customer, if they wish, we can look at their use of our tool. What kind of suggestions are they accepting and rejecting? And this becomes a signal to fine-tune the neural network for their use case. So this adapts to the current objective of the customer. Do they wish to maximize their profits or throughput, or minimize the risk of delays, or any kind of trade-off between these different objectives? Next slide, please.
And then it's demo time. I will switch over to the demo. Get this out of the way. All right. So this is what our software solution, or the main page, the planning page, looks like. So we have scenarios, as I mentioned, and then we have cargoes in different stages of its life cycle. Basically, we have inquiries or preliminary COA cargoes, or the confirmed cargoes, and then as you plan them, they go through this process. For this demo, I created a short list of 28 cargoes, and then I have shortlisted 5 vessels out of this. By the way, now that we're talking about AI, I've generated this data set with an LLM, so it's not exactly realistic, but you can still get the idea. All right, the first thing I wanted to show you is creating a new cargo with the cargo dictation. So I'm going to create an inquiry, and you could, by the way, you can do this on your phone as well. So I'm going to tap here, and then I'm going to dictate a cargo. 20,000 metric tons of methanol from Fujairah to Singapore. Earliest loading December 1st, latest loading December 14th, loading rate 200 metric tons an hour, discharge rate 200 metric tons an hour. And then we're converting the speech to text. Let's see, this has been a little sluggish, but hope we get the transcript soon. So the idea is that we we do the transcript into this editable text box. So if something was wrong, then you can fix it here. It looks like it's correct. Fujairah to Singapore. Yes, discharge rate. Okay, and then I hit generate order. And now what we're doing is that we're populating this data into the cargo form. And then you can verify that everything is correct and fill in the details that are missing. Oh, this is taking a bit longer than I thought. Okay, here we go. So methanol, 20,000 metric tons, Fujairah, Singapore, loading rates, etc. And then the Laycan, earliest loading, latest loading here. Then I'll give it a freight rate. What could it be? Maybe 40 per ton. And then let's save and close. And here we have the cargo. So now if we wanted to see where do we have any vessels for it, well, I'll use the short list. Well, let's see. Use the short list of vessels and see if it makes sense. Do we have any vessels in the short list? I'll put this down to 1 and current selection only and ask for new voyages because it's quite a big parcel. Confirm. Yeah, we could. So it looks like we could use Genie for it. It would make 15,800 a day. So very quick evaluation of, or like getting a voyage P&L calculated for a cargo. Quick cargo entry, and then you understand, do you have any vessels for it, basically straight away. All right, let's dismiss suggestions for now. I'll show some of the other suggestion features as well. Before I do that, I'll quickly show you the region tool, which people love. So here we have created these regions. So these are just polygons on the map, so anyone can create their own regions if they want. So all the port coordinates that fall inside this polygon are like a shape on the map. They will get classified to belong into these regions. And then we have months here. So if we and we show tonnage and the total cargo amount per region. So for example, if we wanted to now see Far East region, we can click here, and then we see only cargoes loading in that region in that month, and all the vessels that are either open or have some capacity to load cargoes from that region. But now that we're already in the short list, I'll show you a couple of suggestions. So now let's look at Snow White, for example. It's open in Ulsan, 24th of November. And let's see if we have any cargoes in the short list that would, or like, what would be a good voyage out of the 28 in the short list for this vessel. So let's put the max port pairs up now. And we want to consider the short list and the selected vessel, and we want to get new voyage suggestions. So now we're bundling these cargoes. Now it's only 28, so it's very quick. You might have to wait a bit longer if you had like 200 cargoes in the list, but it's still okay. So now where you're seeing the green boxes here, these are voyage suggestions with the port rotation and the individual cargoes included. And then we also show the VCP. This is a capacity utilization metric, and we rank by that because oftentimes you're better off making selections based on the capacity utilization. So then, because you might have one cargo with really good freight rate, and then you would always favor that in the suggestions otherwise. But it looks like we have just a couple of options, either to go from Far East to the US Gulf, 13,000 TCE, total days 45.6. That could be okay. So let's shortlist this one. And then one taking the vessel to Vancouver. And then the question is like, will there be cargoes from Vancouver area? I wouldn't know. A chartering desk person would probably. But anyways, let's shortlist this one as well. So now we have shortlisted a couple of options, and then the others are quite similar to the one that we selected with lower TCE, so we're probably not interested in those. So we shortlisted a couple of options. Now, if we wanted to see what could be next from Vancouver for this vessel, we can get suggestions for this position now. So let's consider all orders actually. Let's make max port fares 2, ask for new voyages, and see if we can find anything from the bigger list of cargoes. So now it's going through 353 confirmed and 32 inquiries. So it's a bit slower. Oh, it looks like we have. I didn't actually go through this in the previous when I was practicing for the demo, but it looks like we have great cargo benzene. So it could be a great combination voyage. So we could just simply add this here. All right, and then you can see the total resulting TCE here for both of these options. And so with the second option, we end up in Hamburg, but that might be okay because there's lots of cargoes probably around there. So now you can, for example, if you want to investigate this a bit further, you can see the more precise schedule, and you can look at the voyage P&L, all the income, bunker cost, port cost, etc. Make sure everything is okay. If you want to play around with the freight rates, you can do that. If you think that you would get $3 per ton more for this, you can see what impact it has on the TCE, etc. We support different bunker grades inside, outside emission control areas, and so on. Now, if I wanted to, well, actually, I'm running out of time. But if you wanted to now compare or create 2 different scenarios, you would have to pick out of these kind of shortlisted options that you have here. You need to pick one option so that you can compare on scenario level. So practically, you would want to probably create these alternatives for a few vessels, and then pick different ones in a couple of different scenarios, and then you can compare on the whole scenario level which of those options, or it's always kind of a domino effect, which of those result in better average TCE for your fleet. All right. Since I'm running out of time now, I will maybe end this here, and then there's the Q&A session, correct?
Well, very good. Okay, we can go into the Q&A section. So just invite Mikhail to turn the camera on. And if anybody in the audience wants to put in questions in the Q&A box, I've got quite a few. Just to start, so I was reading this morning a case study on your website. You actually did a structured analysis where you found that the savings of trying to do it the traditional way compared to your system was 3%. I mean, I guess viewers can read the case study themselves, but maybe you'd like to give a quick summary of that. I think quite interesting. You really proved that the benefit there.
Yeah, yeah. It seems that that this solution. I mean, people would usually think that you need to have a very large fleet and very complex operation to get benefits from a system like this. But it seems like that isn't the case. I mean, definitely you will get benefits if you have a large fleet, more than 100 vessels, and doing multi-parcel voyages. Then this is a very useful tool for different parts of the process, like scheduling the COA cargoes in, doing trade lane allocations, but then also for chartering and also the handover from, if you have separate scheduling team, handover to chartering. So yes, that is a good case for us, but also like simpler, much smaller fleets. If you have, for example, if you're a charterer that has 4 vessels or 8 vessels on TC, and you're commercially operating those or planning the schedule for those 8 vessels, you have your own cargoes. So even with 4 vessels, we seem to be generating savings. So I guess it's primarily bunker cost, some port cost savings, because you might be able to like combine port calls if you're doing multi-parcel. But anyway, even with 4 vessels, you can make the schedule more efficient. Simply, I mean, there are a few different things. Like one is I bet a lot of people were confused about the number of data points we're putting onto the fleet timeline. But really, when you start using it, you probably will need all of that, and that creates like a visual way to see where you might have inefficiencies, and then to try out. For trying out different cases, all you need to do is drag and drop things around. So that's one part, and then there's obviously the all the suggestion or optimization algorithms that help you, and then also it's a tool where you can collaborate. So different people on the chartering desk, operators, if you have like charters who will have supply chain planners, etc., so that they can all look at the same data, and there's like better situational awareness and better understanding of what the future schedule looks like.
Yeah, a ship owner told me once that to get a ship owner's attention, you want at least 2% savings for anything. So I thought you've got this 3% benefit that passes the bar of what's
Yeah, and people save time as well, because for example, one person using, or one of our users was reporting that he's saving 15 hours a week, like when he switched over from, a lot of people are doing scheduling in a spreadsheet, so switching from spreadsheet to Seaber, A, makes the schedule more efficient, and B, saves you time so that you can focus on the other stuff that you usually don't have enough time for.
Yeah, very good. So it's a question for Mikael on the future proofness. So this is another theme we're exploring quite a lot, because it seems like there's 2 ways people present AI. One is when they try and dazzle you with something amazing, but maybe it's only going to last for 5 minutes. But another thing is when we're making an infrastructure that's going to last for the next 50 years. And that seems like what you're creating here is incredibly flexible and fluid, and it's not constraining anybody to any particular software tool or anything like that. Would you say that's your philosophy? Or, yeah.
Yeah, certainly. Like we have lots of integrations already, and we keep making new ones, several per year. And we don't really have any limitations. We tend to build our integrations ourselves. So both incoming and outgoing integrations, we have full control over it. So we can quickly iterate and fix any kind of issues that our customers hit upon. But of course, if a customer wants to build it themselves or have a third party develop it, that's also fine. We have a GraphQL API, which enables easy integration with any kind of system. And yeah.
Yeah, if we try to think what might happen in the next 10 years, I guess there could be new data sources, and also carbon is going to get enormously more complicated with charterers caring a lot more about this. But I guess it's relatively easy for you to, the way you've constructed it openly, you can connect to different things quite easily, I suppose, isn't it? And,
Yeah.
There's yeah, I just wanted to say that there's a lot of really interesting stuff on the roadmap, as you can imagine. Like a lot of them are integration based things, and some of them are just getting the pre-fixture process even more integrated with everything else, like being able to, for example, do bunker planning and in a tool like this is something that I would love to already have in the product, but we can't do everything at once. So
oh, very good. So we've got a question. So LinkedIn's told me this is one of your colleagues in Toronto, but he's asking about, is this a decision-making tool with the power of AI in the hands of a user? I'm not sure where we're going. So I guess the person is making the decision, not the computer. That's the question here, isn't it? I think it's not.
yeah, absolutely. I mean, there are so many soft constraints, and even some of the hard constraints. It's going to be impossible to get it working. So, like, I don't believe that there will be like a black box algorithm or like an AI that does the work of the chartering desk, like, ever, and certainly not right now. So, like, one of the secret sauces we have is that we can kind of put the decisions, or like package the decisions into small enough packages so that people can verify and understand and verify the calculations, etc. So if you get get your 100 vessel fleet schedule for the next 3 months in one go, there's going to be so many problems with the schedule so that it becomes worthless basically straight away. So that philosophy is kind of important for our product.
Yeah, I spend a lot of time trying to compare human capability with AI, as a lot of people I think do as well. But one conclusion seems to me is AI is very good for structured data, but as soon as data gets more complex, then people are much better. I think you had an example. You said, I don't know if there's any cargoes from Vancouver, but probably the chartering desk would know. I suppose that's the sort of thing that a person's maybe much better able to predict than a computer than.
Yeah, absolutely. Yeah, and like all this, relationships with the brokers and charterers and those kinds of like soft constraints that we should not be. We have to minimize the risk of being delayed for this charter because the next year's COA contract is is at risk. Those kinds of things that obviously, and then the relationship itself needs nurturing and so on. So like, there's no way that a software could replace, but it can assist you in decision making and provide easy to understand sort of proposals for you and help you.
Yeah, I quite like that in your case study on the website. If you can say, right, well, every ship is going to turn up on time, or you can do a model saying, well, we're going to allow ships to be a little bit late and see how much that saves us, isn't it? But I guess that's how the real world works. Is people don't get served perfectly, do they? People.
Yeah, I mean that's in the initial presentation I had the science fiction part where I was trying to come up with like different ways of using AI in the chartering process or in the scheduling process, and one of the examples was that you could maybe just talk to or chat to the system and say that, hey, I have some delays here. There was something happening at a terminal. I have some delays here, and now I need to mitigate the risk of being delayed for this particular charter. Like these 4 charters, you can be a little bit late from the lake camp, but for this one you have to. And then with this kind of input, then our system could propose different scenarios how to deal with the situation, how to reduce the delays to begin with, but then how to value between the different cases, etc. So. That we don't have yet, but that's something I would love to have, of course.
Yeah, very good. So we've got a question now. I think this is coming from a competitor. So LinkedIn says that Anuj is in Mumbai and works for Caloris, which is a software company. How can agentic AI help vessel optimization and emission compliance? You're up very late, Anuj, but I think we kind of showed it, didn't we? I mean, this is agentic.
Yeah, well, emission compliance. I don't know if AI can really help with that, or I can't think of a use case for that. But that's certainly something that makes using a software like ours even more important in the future, because there's so much new regulation coming and so on. So for individual people to keep up with all that and to like take absolutely everything into account when you're doing P&L calculations and comparing options and so on. So it's even more reason to upgrade it from a spreadsheet to something else.
Yeah, well, I mean, yeah, we've done webinars with your fellow countryman from I forgot his name, but about emission compliance. The modelling in the future is going to be enormously Risto. That's it. Yeah. When he's involved in biofuel transportation, so the cost of the carbon and the biofuel, the carbon used to move it, is a factor in the whole picture of the biofuel. So, and charterers are going to make promises to cargo owners about how much carbon they're going to emit during the voyage. And I mean, I would have thought as this stuff comes in, your structure is you can build stuff to handle these complex factors.
Absolutely. But yeah, building Fuel EU, for example, is like, reading through the EU directive and try to figure out how to implement that into code is quite a nice challenge. Didn't get it right on the first try, I have to say, but a little bit of iteration, it was working.
I mean, for these emission-related things, I think it's agentic AI is probably not so relevant. It's more like a deterministic algorithm which need to be applied there. But of course, in terms of optimization, you can reduce the use of bunkers, which reduces your emissions. So in this way, you can utilize the optimization algorithms and AI to just find ways to use less bunkers to achieve the same cargo transports.
Yeah, but it's also, I guess there's going to be enormous complexities that we don't know about. It's having a structure ready to handle this. That's what seems like one of the most important sort of stories here, isn't it? That this is fluid enough; it can handle as many factors you can throw at it, and companies aren't restricted to anything. The sort of graphical structure. There's sort of codes and more data sources and more constraints, and there's no limit to the computational power you can use to find the right answer. And
yeah, but
exactly.
Like one issue with if you would just make a standalone agentic AI system for this kind of thing is that then it's like a black box, and we found that people don't want to use black boxes. They want to stay in control. Like there's been black boxes for optimizing vehicle routing problems since like the late 50s, and for more advanced transportation problems like the pickup and delivery since mid 90s. But we haven't found anyone really who has taken this into use, because usually you give it your cargoes and your vessel schedules as inputs, and you get something out, but you don't understand how were the decisions made. You're not fully in control of these minute details, like if one cargo, you need to minimize the risk of delay there, while in some other place you need to maximize profits. Usually you're not in control in that way there. Well, in Seaber, you can focus on a subset and choose your objectives per vessel or per cargo, and you can see each atomic change to your schedules and accept or reject.
yeah. Another thing I'd like to ask you about do you think this improves transparency in the chartering process? Because I mean, when the actual chartering process has all been quite secret for hundreds of years. I mean, I was in a pub once and somebody explained how tanker chartering actually works, who was a broker, but by and large, nobody knows. But a system like this, people can see the decision models and why people are making certain decisions and bring other people involved, and makes it much more clearer, isn't it?
I think it's end of the day, it's really up to the parties involved to, if they, I mean, you have to, obviously in a software like ours, you have to stay in control of what is shared and to whom. So that's absolutely going to be in like that the ship owners can control, the charterers can control, of course, everything. But it makes it possible and even easy. So like, when you order a parcel from Amazon or somewhere, and you can track the delivery, that sort of stuff is very, very easy to implement on top of, or we practically already have it, of course. But yeah, it gives the opportunity to increase transparency.
Yeah, very good. You didn't mention anything about clients. I don't know if there's anything, obviously, a lot of it's secret, but if there's any clients you're able to mention, that might be something people are interested to know about, is it?
Well, you saw some of the logos in one of the slides, but our first clients were charterers. So we had a forestry company, Stora Enso, from Finland and Sweden. And then the second client was Neste. Neste has been a very good client since like 5 years ago, something like that. They're very heavy users of our software. Since then, we've been focusing more on ship owners, and basically, to summarize, I would say that we had the first product was a scheduling product, not so much chartering. So then the target segments were smaller. Only the really big ship owners that have separate scheduling departments, etc., and then the cargo owners, etc. But we didn't really have good tools for the chartering process originally. But now we do, and there seems to be a lot of traction on basically any ship owner that has a chartering desk. Well, you saw the demo, and you can kind of you kind of understand from that this is you know, it's a couple of steps forward for the, you know, conventional chartering process. So so now yeah, there's the sales pipeline seems to be very healthy at the moment, and we have yeah, lots of really interesting conversations with very big ship owners ongoing, and trying to run really fast to like complete everything, all the requirements. And you know, like every client has something a little bit unique, so that's it's always a little bit of tweaking and configuration and sometimes even development work needed to like onboard new customers, especially if it's a new segment or so on.
Yeah. And I'm also fascinated by the overall carbon emissions impact on a ship owner, because this shows you how to use your fleet more efficiently, spend less time in ballast, or there's a potential to do that. I mean, if people are looking 1-2% savings on their total bill, which they may need to get a better CII grade, something like this,
Yeah.
probably get there, isn't it?
Yeah, exactly. I mean, we kind of support in optimizing also for all of that, and like EU ETS, fuel EU, CII ratings, etc. So absolutely, the biggest part of the savings comes from bunker consumption. So like, you know, reduction of ballast distance, or increasing the capacity utilization, so that you're you know, minimizing the waste basically, and that often then translates into bunker cost savings.
Yeah, when companies are using different fuels, one with lower carbon than another one, that's almost another complication to the calculation, which I suppose is
Exactly. So yeah, that's I mean, that's part of every voyage management system estimator as well, like to be able to switch between the grades. But absolutely, that's something we must have as well. Emission control areas and so on.
Well, that's fantastic. Well, we don't have any more questions on the board there. That's all the questions I thought of. I don't know if there's any last words you want to share or anything like that before we finish, or if there's or if you want to take anything else you wanted to.
Yeah, this was fun, and it's the second webinar that I've ever spoken at, and I think I want to do more of these.
Very good. Yeah. Have any last words, Mikael, or do you want to finish with?
Oh, thank you for organizing. This was a pleasure.
Oh, that's very good. Okay, well, I think we have a whole new subject we haven't talked about before, and hopefully we'll be coming back to this again. But thank you very much. I shall pass back to Farah for the closing words. Cheers.
Thank you to our guest speakers from our sponsors, Seaber, Mikael Sand, Arto Vitanen, and to our audience members for participating. A video recording of today is available on our YouTube channel, which will be sent to you soon with contact details. Goodbye.
Bye-bye.
Bye.